Hi everyone, welcome back to KW Ross Patterns. We are going to continue with some lessons in geometry today, and I'm going to be talking about some theorems that will arrive from angles and things that are formed inside of angles. So we're going to talk about theorems today, and we are going to talk about inscribed angle theorem as one, and we are also going to talk about the secant angle theorem and other things. All right, so we're going to talk about, first and foremost, we have here the center, right? And this angle that's formed here from the center, we call this the central angle. All right, the central angle. Now the central angle, right, is the vertex is at the center of the circle, and we call this the arc. All right, we call this the arc. I want to put it in different colors so you can see it. This is an arc, right? And this is a minor arc because it's less than 180 degrees. So this is a minor arc here. And I'm going to label this as A, B, label the center O, C. So minor arc, and we denote arc as AB. That's the symbol for minor arc, AB, right? And the relationship between the central angle and the intercepted arc, which is a minor arc, they are going to be congruent. Okay, so the central angle is going to be equal to arc AB. All right, just want you to know that. Now there's also the inscribed angle here, the angle that's coming, that is going to be not at the center, but it's going to be on the tip or anywhere on the edge or the circumference of a circle. The vertex is on the tip, is going to be what we call the inscribed angle. So this is the inscribed angle. All right, this is the inscribed angle. Now the inscribed angle, the relationship between the inscribed angle and the central angle is that the inscribed angle is half of the central angle. Half of the central angle. All right, that you need to know. Also, the inscribed angle here, it is going to be half of the intercepted arc. So inscribed angle, another thing that you need to know, it is going to, inscribed angle is going to be the half of arc, and arc AB, or you can write it as this is arc AB is going to be divided by 2. So the inscribed angle here is angle, the measure of angle ACB. The central angle is a measure of angle, we write it like that, right? Measure of angle AOB. All right. Now, so that's one concept that we need to remember. And if we look in from a standpoint and we want to call this A, we can say that in general, A is equals to half of the minor arc here. Now, what we also need to know is that since we're talking about minor arcs, I'm going to talk about major arc in a bit. So let's look at this segment here, right? Now, I have this segment, and we call it a secant line, right? And it's touching this circle in 2 places, and it extends outside. All right, it can be just right by the end here. We also, is another name for it is a chord, but we usually, in reference to theorems, we call it a secant line. And then we have the tangent line here. The tangent line, the difference between the tangent line and the secant line. The secant line that touches the circle, the secant line touches the circle in 2 places. All right, on the edge of the circle. It does not pass through the center, only the diameter passes through the center. And you have the tangent line, right? It touches the circle in 1 place, and we call this the point of tangency. The point of tangency. So that you need to know, tangency. you need to know that also. Okay, now there is a relationship that is being formed right here between these two. All right, not just this. Actually, let me make this bigger, the arc this bigger, so you know that I'm not talking about this angle right here. I'm talking about this entire angle right here. Okay, so you need to know this because it is very important that you need to know this. Now this angle right here, we call it a tangent, secant tangent angle. It's going to be, you see that this arc right here, and I'm going to draw it in a different color. This arc right here, the orange one, this is our minor arc again. All right, this minor arc. I can label this X. This is Y. And if I want to say, call this Z. All right, minor arc. Right, so minor arc here is X, Y. Right, that's our minor arc. All right, that's our symbol for arc. And this angle that's formed here from the, we call it the secant tangent line, the angle right here, secant tangent angle. There's a relationship between this angle right here and the arc. This angle is half of arc XY. Now it's half of arc XY, meaning that it is half of whatever measure this arc is. This angle right here is half of XY, just the same as how the inscribed angle is half of the intercepted arc. Okay, now also what we need to know that because on any circle, given circle, we also have a radius and a diameter. So if we have the radius here, and for argument's sake, this is our radius. All right, that is the radius actually. This is going to form a right angle right here. The radius to the tangent line is going to form a right angle right there. And if you're doing a math where you're given the measure of this, you can find the measure of this angle right here, because if this is 90 degrees, whatever this secant tangent angle is, you can subtract that from from 90 degrees, and you get your answer for here. Now, say for instance, if I have another point on here, anywhere on here, we use X, Y, Z. We can say W, X, Y, Z. Now, what you need to know is that, and I'm using a different color right here now. This line here, maybe I should use brown. Let's use brown. Sorry. This arc right here, the bigger arc, which we call it the major arc. All right, this major arc. So our major arc here, this is our major arc. And we use 3 numbers here because major arcs are more than 180 degrees. So we have major arc as X, W, Y. This is our major arc. All right, X, W, Y is our major arc. So, so we have our inscribed angle theorem, and we have our secant tangent theorem. That's another one, or secant tangent theorem, inscribed angle theorem. And we can say it another way. Instead of saying that it is half of this the central angle or half of the intercepted arc, we can say the minor arc here is twice the inscribed angle. So the minor arc, whatever we have here, arc AB, is 2 times the inscribed angle. All right, that's another reverse way of saying it, but don't mix it up. Do not tell me that inscribed angle is 2 times the arc. No, it's the reverse. It's the arc is 2 times the inscribed angle. Okay, and this we call it, as I stated before, is the secant tangent theorem. All right, the angle that's formed there between them, there is a relationship between the arc. All right, and you need to know that. Thank you for watching. Please like, share, and subscribe my videos with others around the world so that they can gain a wealth of knowledge on this topic. Thank you, and I'll see you shortly. Bye.